In this section, we're actually going to work the previous sections backwards. Given roots, now let's find the equations. It says directions, write an equation that could represent the functions with the given zeros. And that's the whole purpose of why we did what we did at the last in the last section. We have roots of 1, 2, and 5. So therefore, my function, since 1 is a root, that means that x minus 1 is a factor. Since 2 is a root, that means that x minus 2 is a factor. And since 5 is a root, that means that x minus 5 is a factor. So technically, that's your answer. However, we are going to get some practice multiplying these out. Distributive properties, so let's go ahead and do that next. Just pick 2 at a time to multiply. I'm going to multiply these two first. So that's going to give you x minus 1, just bring it down, times x is x squared. And let's get into a habit of, as we multiply these together, negative 5x and negative 2x, go ahead and combine those. It'll save you some time. Then negative 5 times negative 2 is a positive 10. Now, let's distribute x minus 1. X times everything would be x to the third minus 7x squared plus 10x. And negative 1 times everything would be negative x squared plus 7x plus 10. Combine all your like terms, and you get f of x is equal to x to the third minus 8x to the second plus 17x plus 10. So there's your function that has those three roots, and you could work this like we have been, and you could find out that that does check out. All right, number 2. Let me zoom in so we can see a little bit better. Your function, if these are my roots, then that means that x plus 7 would have to be a factor, x minus 1 would have to be a factor, or x plus 1 would have to be a factor, and x minus 3 would be a factor. Then we simply FOIL it out. Bring down your x plus 7. Multiply these two gives me x squared, negative 3x and 1x gives me negative 2x minus 3. Now let's distribute our x plus 7. Multiply by all three gives me an x to the third minus 2x squared minus 3x. And you can start using the trick as well. When you distribute the 7, listing it below, that'd be a positive 7x squared, a negative 14x minus 21. Then all your like terms are lined up. And your function is equal to x to the third plus 5x squared minus 17x minus 21. Number 3. Here's my roots. So my f of x is equal to, I would have to have a factor of x plus 2 and a factor of x plus 4/3 and a factor of x minus 2. Okay, I don't like this x plus 4/3, so let's do something with that. And you can actually use the same trick that you do on slip and slide. If you have a factor of x plus 4/3, you can move that 3 up front, because look at this. If you did 3x plus 4 instead, and you set that equal to 0 and solve it, move the 4 over and divide by 3, and guess what? You get the same negative 4/3. So instead of listing as x plus 4/3, you can list it as 3x plus 4, because that would also give you a root of negative 4/3. Now, multiplying this together, notice something, please. X plus 2 and x minus 2 are both factors. That means those are conjugates of each other. I would definitely multiply the conjugates first, because when you multiply conjugates, you have a shortcut. You can just multiply the first two terms and the last two terms, and it's done. So therefore, that's going to be a whole lot quicker and easier if you'll do that first. So now you have x squared times 3x, which is 3x to the third plus 4x squared. Negative 4 times 3x is a negative 12x, and negative 4 times 4 is a negative 16. There is your function. Next up, your f of x. You have a pair of irrational roots here, so that means that since positive root 2 is a 0, so that means x minus root 2 is a factor, x plus root 2 is going to be a factor, and x minus 1 is also a factor. And again, you do have, those conjugates here. So multiply x times x is x squared. Negative root 2 times a positive root 2. If you multiply a root times itself, it removes the radical. So that'd be simply x squared minus 2. And you can check that. Set it equal to 0. Move the 2 over. Take the square root, and you get that plus and minus root 2. X squared times x is x to the third. X squared times negative 1 is negative x squared. Negative 2 times x, and negative 2 times positive 1 gives you this, so there is your function. Number 5, your function roots are shown, so therefore if plus 2 root 3 is a root, then that's negative 2 root 3 is a factor. Its conjugate will also be a factor, and notice those always come in conjugate pairs. If positive 1 and negative 1 are roots, that means that x minus 1 and x plus 1 would be factors. And what I'm going to do to multiply this together is I'm going to multiply my conjugate pairs. I'm doing x times x is x squared. Negative 2 root 3 and positive 2 root 3 would be negative. 2 times 2 is 4. Root 3 times root 3 is 3. So instead of 4 times 3, let's write that as 12. So there's your first conjugate pair being multiplied. Now let's multiply x minus 1 times x plus 1. That'll be x times x, and negative 1 times positive 1. So there's our second one. Now let's multiply those two. X squared times x squared is x to the fourth. X squared times negative 1 is negative x squared. Negative 12 times x squared is negative 12x squared, which will combine. Negative 12 times a negative 1 is a positive 12. So my final function is x to the fourth minus 13x to the second plus 12. And again, you could take that, find the roots, and you would should get those 4 roots. Number 6, your function is going to be, since negative 6 is a root, you'll have x plus 6 as a factor. Now we're getting a little bit more difficult. Since 2 plus root 5 and 2 minus root 5, that means that I will have x minus 2 plus root 5, and I'll have x minus 2 minus root 5 as factors. So those, let's multiply them together first. But before we do, let me show you a trick. You can multiply these out all the way if you would like to. However, there is a shortcut. Watch this. Let's distribute that minus here. That'd be x minus 2 minus root 5 if you got rid of that. Distribute the minus here. That'd be x minus 2 plus root 5. Okay, now if you'll look at those two factors, each of those factors have 3 terms. However, if you'll take now and group these together and these together, look what you got. You have x minus 2 minus a root 5 and x minus 2 plus a root 5. The only difference between these two terms is that minus and plus right here. These are conjugates of each other. And if you would like to, this is so much quicker. Multiply these conjugates by taking your first and multiplying those together. That'd be x minus 2 squared. Then taking your last and multiplying that together, and that'd be a positive. Root 5 times root 5 would be 5. And that's going to speed this up so much instead of having to FOIL that out. That would take forever. So now you have x plus 6 times x minus 2 times x minus 2 would be x squared minus 4x plus 4. Write down your plus 5. And let's go ahead and combine 4 and 5, and we'll just erase it here so we don't have to rewrite it. That'll be plus 9. Now we can just multiply these out. X times everything will be x to the third minus 4x to the second plus 9x. That's a 2 here. Done with the x. Now let's do 6. So that'd be plus 6x to the second minus 24x plus 54. Which gives me a final answer of f of x is equal to x to the third plus 2x to the second minus 15x plus 54. Okay, number 6. In this problem, since negative 6 is a root, that means that x plus 6 is a factor. Now, a little bit more difficult here. We have a binomial. So since 2 plus root 5 is a root, that means x minus 2 plus root 5 will be a factor. Since 2 minus root 5 is a root, that means that x minus 2 minus root 5 will be a factor. Now, I'm going to show you a method for multiplying these out because it's going to be pretty tough doing it the other way. Let me show you the other way that you could do it, and if you don't understand the shortcut, this is fine. Let's go ahead and get rid of our parentheses here inside. That'd be x minus 2 minus root 5. and this will be x minus 2 plus root 5. So one step or one method of doing it is you could take these two and actually distribute them out. X times x times negative 2, and x times root 5. And you'll have 9 different things to multiply together there. Or you can actually take and group these back together. Because if you do, you have 3 terms and 3 terms. If you group those back together and treat this and this separately and this separately, look what you've actually got. X minus 2 minus root 5 and x minus 2 plus root 5. You have conjugates. So you can treat them like conjugates. And remember how we multiply conjugates get together. There's a shortcut, x times x, negative 1, positive 1, and you're done. So to multiply conjugates, you only have to multiply first and first, last and last, because the middle terms are going to cancel anyway. So here we can multiply x minus 2 times itself, and that'd be x minus 2 to the second power. And you multiply negative root 5 times positive root 5, and that will give you a negative 5. So that's going to be so much faster and easier than to actually distribute all that stuff out. So now you have x plus 6 times, we've got to do x minus 2 squared. That'd be x squared minus 4x plus 4. And you can bring down the minus 5. So you now have x plus 6 times x squared minus 4x minus 1. Now we do have to distribute this out though. X times x squared, or x times everything actually, it'd be x to the third minus 4x squared minus x. Move on to 6, multiplied by everything, would be plus 6x squared minus 24x minus 6. So our new function f of x is equal to x to the third, a positive 2x squared, a negative 25x minus 6. So there's your function. Okay, number 7. Now we have some examples with multiplicity. 3 is a root twice. It has a multiplicity of 2. So my function, these are going to be pretty easy. My function will be x minus 3 times x minus 3. Or we can put that as x minus 3 squared and then x minus 5. However, to do x minus 3 squared, you do have to do x minus 3 times x minus 3, which is going to be x squared minus 6x plus 9. The shortcut there, if you don't remember it, and I kind of use it on the other one, to square something out, you square this, multiply the 2 together and double it, and then square this. That's it. X squared, multiply the 2 together gives you negative 3x, double it gives you negative 6x, and then square the 3 gives you 9. Now let's multiply everything together here. Let's actually do it backwards. Let's multiply x times everything. That'd be x to the third minus 6x squared plus 9x. Then multiply negative 5 times everything. Gives you negative 5x squared, a plus 30x minus 45. So my function is going to be x to the third, a negative 11x to the second, a positive 39x minus 45. All right, number 8. My function, you got to be careful here. Since 0 is a root, you could do x minus 0 as a factor, but the minus 0 would be kind of pointless. Since 1's a root, that means x minus 1's a factor. Remember the trick I showed you on the 5 halves. That'd be x minus 5 halves is a factor, which would be 2x minus 5. We can write it like that. It looks better. And that's a factor with a root with a multiplicity of 2, so there's going to be 2 of those. Okay, so let's multiply these 2 together, and I'm going to go ahead and square this. So that'd be x squared minus x will be our first couple multiplied together. Times, to square this again, you can use my shortcut, 2x times itself. Multiply the 2 and double it, be minus 20x and then plus 25. So now let's distributive property for these. X squared times everything will be 4x to the fourth minus 20x to the third plus 25x to the second. Distribute negative x gives you negative 4x to the third, negative 20x to the second plus 25x. So therefore your function will be 4x to the fourth. Negative 20 and negative 4 would be a negative 24x to the third. 25 minus 20 would be a positive 5x to the second plus 25x. There's your function. And I did make a mistake right here when I did negative x times 25. That should have been a minus 25x. So let's change that to make that right. There we go. The next one. Negative 1 has a multiplicity of 3. So my function is going to be x plus 1. And there's going to be 3 of them. So you could do to the third power. But I'm going to go ahead and do 3 of them. And then x minus 5/4, which again, you can use your bottoms up trick. That'd be 4x minus 5 will be your last one. So there's all your factors. You can use your shortcut for squaring here. Actually, so that my x plus 1's out front, I'm going to multiply these two. So I now have x plus 1 times, well, no, here we go. Let's do this. Multiply these two and these two together. So the trick here would be x squared plus 2x plus 1. And then multiplying these two together gives you 4x squared. You can go ahead, this would be negative 5x plus 4x, which would be negative 1x, and then minus 5. Now let's distribute these two. X squared times everything gives you 4x to the 4th minus x to the 3rd minus 5x to the 2nd. 2x times everything gives you, let's see, that'd be 8x to the 3rd, so plus 8x to the 3rd. 2x times negative x gives you a negative 2x to the 2nd and negative 10x. And now 1 times everything gives you a positive 4x to the 2nd, a negative 1x, and a negative 5. So therefore, your function is going to equal 4x to the 4th. Negative 1 and a positive 8 gives you positive 7x to the 3rd. Negative 5, negative 2, and a positive 4 gives you negative 3x to the 2nd. Negative 11x's minus 5. Okay, number 10. Since negative 1/2 is a root, that means x plus 1/2 would be a factor, or x minus negative 1/2, which you can use your trick on. That's going to be 2x plus 1. And that's actually a factor twice. And then 4 is also a root twice, so x minus 4 would be a factor twice. So we can use our shortcut for squaring. So my first one, square the 2x, multiply them and double them, and square the 1. Square the x, multiply them and double them, and then square the negative 4. Then we just have to distribute this out and we're finished. Multiply 4x squared times everything will be 4x to the 4th. Let me scroll up just a little bit. 4x to the 4th minus 32x to the 3rd. Let me underline this. And then plus 64x to the 2nd. Move on to the 4x. That'd be a positive 4x to the 3rd. A negative 32x to the 2nd plus 64x. And then 1 times everything gives you positive 1x to the 2nd minus 8x and a positive 16. Now combining all your like terms, f of x is equal to 4x to the 4th. Negative 32 and 4 is a negative 28x to the 3rd. 64 minus 32 plus 1 will be 32 plus 1 is 33. X to the 2nd. 64 minus 8 would be a plus 56x plus 16. Okay, in this final section, we're going to be talking about complex zeros. And now there is a rule, and this actually also applies to irrational zeros. It's called the conjugate root theorem. It says that if a polynomial function has a complex root a plus bi, then its conjugate, which we know would be a minus bi, would also be a complex root. So pretty much what does this says? It says that complex root comes in pairs. They come in conjugate pairs. If 2 plus 3i is a root, then 2 minus 3i has to be a root as well. So if you have one complex root, that means that really you have two. So here we go. Number 11, Same thing. Your function is equal to, if 5 is a root, then that means, wait a minute, let's do this first. If 3i, now that is 0 plus 3i. If 3i is a root, then 0 minus 3i will also be a root. So let's go ahead and do that first. So therefore, your factors are x minus 5, x minus 3i, and x minus negative 3i, which is x plus 3i. Always multiply your conjugates first, so that'd be x minus 5 times x times x is x squared. The middles would cancel, so now all you have to do is multiply 3i times 3i, which is 9i squared. Now 9i squared, anytime you have an I squared, reminder, I squared is equal to negative 1. So this will be negative 9 times negative 1. So to save ourselves a step, let's go ahead and change that to a plus 9. Then distribute and you're finished. X times x squared is x to the third plus 9x. Negative 5 times x squared is negative 5x squared and negative 45. And I don't really like it in that order, so let's go ahead and flip-flop the middle two. X to the third minus 5x squared plus 9x minus 45. There's your function. Number 11, notice these came in pairs as well. If 2i is a root, that's 0 plus 2i, then 0 minus 2i would also be a root. So therefore, your function is going to be x minus root 6, and x minus negative root 6 will be x plus root 6. Then your other two factors will be x minus 2i and x plus 2i. So we have a couple of conjugates to multiply together. X times x, x squared. Negative root 6 times positive root 6 will be negative 6. X times x, x squared. Negative 2i times positive 2i will be a negative 4i squared. And again, we can save ourselves a step by changing I squared to negative 1, and that makes this a plus 4. Distribute. X squared times both gives you x to the fourth plus 4x squared. Negative 6 times both gives you negative 6x squared minus 24. So your final function is going to be x to the fourth minus 2x to the second minus 24. Number 13. If negative I is a root, that means that positive I is also a root. So your factors are going to be x minus 2 root 5 and x plus 2 root 5. Again, a couple more conjugates. And then x plus I and x minus I. Multiply your conjugates together. X times x is x squared. Negative 2 root 5 and positive 2 root 5 is going to be a negative. 2 times 2 is 4. Root 5 times root 5 is 5. So that'd be a minus 20. X times x, x squared. Negative I times positive I is a negative I squared. So that's going to be minus negative 1, which would be a plus 1. Distributive. X squared times x squared is x to the fourth. X squared times 1 is a positive x squared. Negative 20 times x squared is a negative 20x squared, and negative 20 times 1 is a negative 20. So therefore, my final function, f of x, is equal to x to the fourth minus 19, x to the second minus 20. Now, if you were to, we worked these problems here backwards. If you were to work this backwards, you could use basic quadratic type factoring to factor that. Okay, the last one. 3 plus I is a root. That means that 3 minus I is also a root. And we can use that shortcut that I showed you in the last section on this one. If f of x is equal to a negative 4 is a root, so x plus 4 is a factor. Here you're going to do x minus 3 plus I has to be a root, or a factor, excuse me, and x minus 3 minus I as well. Okay, and here's that shortcut one more time. Break down the x plus 4. Let's get rid of our parentheses here. That'd be x minus 3 minus I, and this would be x minus 3 plus I. These two we're going to group together, these two and these two, and leave those by themselves. And now we can see that these are conjugates. The only thing separating them will be a minus and a plus sign. That's the only difference. So let's leave our x plus 4. Bring it down. Now to multiply these together, we're going to multiply our first group times our first group. X minus 3 times x minus 3, that'd be x minus 3 squared. A negative times a positive I would be a negative I squared. There's your shortcut to multiply conjugates. Multiply first times first, last times last. To clean that up, let's bring down our x plus 4. We've got to do x minus 3 times itself. That'd be x squared minus 6x plus 9. Minus I squared is a negative 1. So we can change that to plus 1. So we now have x plus 4 times x squared minus 6x plus 10. Now distribute and we're done. X times everything will be x to the third minus 6x to the second plus 10x. 4 times everything will be a positive 4x to the second, negative 24x, and a positive 40. Combining all of these like terms, and your function is now going to be x to the third, negative 2x to the second, negative 14x, and a positive 40.